This task is from our writing and graphing linear equations unit. The lesson is write equations given parallel or perpendicular lines. On this task, we are pulling together those two pieces that the students have just learned about, which is information regarding parallel and perpendicular lines. At the top of this task, you will see it says, consider what you know about slopes of parallel lines and slopes of perpendicular lines. You have learned all the pieces needed to work through the problems below. So we want them to think about how can you find the equation of the line if you know slope and a point. We found that when we tried this the first time without that piece at the top, students really didn't have a launching point. They felt like they weren't quite sure where to start. So the first piece, we have write an equation in slope-intercept form that passes through the given point and is parallel to the given line. So you can see we're given a point and we're given the equation of the parallel line. What students should remember is that parallel lines have the same slope. And when you look at the next part, is asking you to do the same thing, but this time you're given the equation for a perpendicular line. In regards to perpendicular lines, we want students to remember that the slopes are negative reciprocals of each other. So once we identify that first piece, students feel a little bit more confident to keep going. So they have figured out what the slope portion is, and now they can go a couple different routes. Some students chose to go ahead and graph, so they would plot the point given, and then they would use that slope to see what the graph looked like for that line. Other groups use the slope and the point provided to find B in slope-intercept form. So they put the slope into the equation, and then they also plugged in the point -1, 2, or the point 4, -1. We found that a lot of students relied on the graph to help them kind of do a self-check. So they would graph the given line and then they would graph the equation that they had come up with just to kind of verify if the graphs were showing what they should show. If they aren't parallel or they weren't perpendicular, then they knew they had made an error and needed to go back. They should have gotten that the equation of the line for the parallel prompt was y equals -3/5 x plus 7/5, which you can see graphed on the screen. For the perpendicular question, they should have found that the equation was y equals -1/9x minus 5/9, which you can see graphed in red. As you can see, this is what the student's graph should have looked like when they were checking themselves. So at the top, we can see that the equation I came up with compared to the initial equation given in the prompt, they do show that they're parallel, especially if with Desmos you can zoom really far out just to make sure. On the lower picture, you can see our perpendicular equation, so those do indeed intersect, and I know we can't be 100% accurate on this, but hints would be that maybe if the lines were intersecting at odd angles, not those perfect 90-degree angles. One option you can do with your consolidation piece is use Desmos point slope form graph. So it's just as quick as typing in slope intercept form, but if you like to use that, you click on the 3 lines in the upper left corner and just click on lines : point slope form. And it kind of allows you to manipulate that graph. Whereas when we do the y equals mx plus b and just type it out, it doesn't really let us maneuver things around. So this task is asking our students to take pieces that they already know in order to create an equation to match some information. They should know enough about parallel lines, enough about perpendicular lines, and enough about slope to be able to put the pieces together. So that's really why we wanted them to do this task as an investigation, just to listen to the conversations and see how do they feel and are they confident about the material that we've just talked about, we've just learned, and can they apply it to this situation? Because they really did have all the pieces they needed for this task.